And I think it should be good. See a couple of y'all in chat. Just make sure we're live here. Yeah, it looks good to me. All right, cool. Welcome back. Starting a little bit early, so I'll hang out for a second. We've got asteroids today is the goal here. Pop this chat out. My streaming muscles are a little bit rusty. There we go. All right, so we've got asteroids today. We've got two things to work on. We built particles last week. So this should just run. I haven't updated anything. So we've got our game. This does have sound. I'm not playing the sound through the stream right now. If we hit new game, we can choose a ship choice, blow stuff up. We get particles. I think I'm going to leave the particles as like this kind of random color rainbowy effect. We don't really have asteroids levels yet. Asteroids levels spawn a specific number of asteroids. We're not keeping score yet either. We don't have a life system, although if I run into this ship, you should die. Also, as you could see there, if you do spawn and there's a meteor, you kind of just spawn forever. And you can see all the game overs that just occurred because we shorted out our life system. So there's that, and then there's input management. So the input today is kind of monolithic, right? This player movement system here takes 1, 2, 3, 4, 5, 6, 7, 8 arguments. And while 8 arguments isn't like the most I've ever seen, it is not my favorite amount. And the lines of code here are from like what, 60 to 160. So it's like 100 lines of code. And there's sections in here that are kind of like completely irrelevant, if that makes sense. So we've got keyboard input, pressed space, and this whole chunk could just be a different function. So I'm thinking we take that. Hey, Prince. I'm thinking we take that and we split it out into a separate function. And when we do that, we actually put like a little booster on the back of the ship as well. Because if we split this out, then we can check for space in that other function. And it can handle whether the booster is live or not, whether it's pressed or not. I love that the ease function on the ship is slowing down after it accelerates. It is momentum based, but not, like it doesn't have a deceleration factor. So you can see here, I've got actually the movement factor decay is commented out. We don't have one. So theoretically, if you were moving, it doesn't currently decay that movement and you would just move like it's in space forever. But if you go back and you face the other direction and you power the other direction, you're now kind of pushing against the thrust that you had created before. So it slows you down over time and then sends you the other way. So you do get this like nice movement, kind of the ship has weight to it effect. But it's not in actual like regular asteroids, the ship does stop, it decays. I don't know if that's something I want to implement or not. I assume that we probably will, because this is meant to be kind of like a more faithful refactor or a more faithful implementation, other than the sprites and everything. The other thing is that we've got, I need to turn Argus off at some point. Come on, Argus. The other thing is we've got our space sheet here. And inside of here, if I zoom in far enough, maybe I won't be able to. There's these little ships here, very, very small. They are mirrors of the big ships, so we can use those for like the life system instead of like hearts. So we can put ships up in the side. Congrats on squashing that mem link. Must be satisfying. Well, I was gonna turn it into a video, honestly. And then the framework itself fixed it like at the source, if that makes sense. So I could still make a video on it, but it's a little bit weird to make a video on something that like doesn't need work anymore. I think I might construct a fake scenario for memory leak kind of stuff. Maybe use DAT or something. So yeah, Leptos had a memory leak in their router implementation, and 0.6.11 fixed it. So where is it? Yeah, even better. I got to fix for free. Exactly. You know, memory leaks aren't like super common in Rust, so when they pop up, they tend to be noticed and fixed, which is not the same as some other ecosystems that I've used in the past. This is quite a few changes since 0.6.10. All examples are running unstable right now, which is the vast majority of the changes. So they've changed everything in the examples in the Leptos repo to be running on Rust stable instead of Rust nightly. Rust nightly can cause a couple of issues in CI if you let it just like update randomly and don't pin to one. Yeah, that was the memory leak we were talking about, Prince. The thing on This Week in Bevy. I want to say this is it right here. Global routers count, fetch, add 1. So I think before this was just kind of like sitting out here growing and growing and growing and growing, and it wasn't really that big of a deal. Like the memory on a 256 megabyte RAM deployment would crash like once every week or two, depending on how much traffic. But it was growing over time, and I think that was it right here. It was just kind of like we have this global state in static, and it just keeps growing and growing and growing. But yeah, glad that that's over. So let's start with the. You want to start with the live system or the input refactor for Asteroids? I think for the input refactor, we might use Leafwing. Although we don't really need Leafwing because we're not going to have multiple input configurations, which is really what Leafwing is most useful for. Yeah. So I think I'll start with the input refactor and then we'll do the lives afterwards, if nobody has an opinion. So what do we want to do here? We have the player movement system, right? We've got a couple of different ways to move. We've got forward, basically, which is like boost, left, right for rotate, and then space for fire. I think firing is probably the easiest thing to abstract. So let's say this is the weapon system. And then left, right. I think the only thing we need here is space. We do need the user facing direction to figure out where to shoot. So where are we getting that from? The transform on the player's ship? Okay, so we'll need this. Keyboard input, query, and time are probably relevant. Last shot is going to be relevant. Images and sheets are probably also relevant. So we may not actually end up getting rid of that much stuff here, but it'll be read only for a lot of it. So let's snag this first and shove it in here. So what we just pulled out is the thing that represents what happens when we press space. And that gives us a very clear insight into like what we are sort of like needing as dependencies. So Rust Analyzer is putting reg squiggles over everything. Keyboard input, the last shot, the time, commands because we're spawning stuff, some transform, which is what we just talked about, the actual sprite sheet itself, and then it looks like we're actually using the movement factor from the ship. So we need quite a bit of this. So we'll get these in. Is there anything that we don't need, actually? I think we need all of it. We don't need... Oops. I need to get rid of that extension. We don't need these to be mutable anymore, I don't think. Right. Last shot needs to be mutable. So we're left with the space sheet, which we're pulling out up here. And we need the transform. I think in the current iteration, we actually don't need vec3y. But we'll keep it. I think user-facing direction is used in other calculations here, so we can't remove it. But we do kind of get to do this, and then the transform here, what came from the ship, right? So in this case, we have this warning. We could do that again. And we don't need to get single mute. We can just get single. This is not mutable. Ship is not something we need. So we can get rid of player ship type and just keep the transform. So our query gets a little bit simpler. This ship goes away. User facing direction is not being used, actually. We're just using the transform. We're really not using that. I guess the laser is taking the movement factor from the ship as its starter. Cool. So we don't need that. Weapon system needs to come up into our player movement system. We have a decision here. Do we want the laser to happen after or before the player movement system? I don't know that it matters. So I'm just going to stick it in here. And if we see anything, then we can fix it. In state, game state playing. Hello, Ghosh. How's it going? How to shoot a weapon. Is that a, like, are you asking what we're doing, or are you asking how to shoot a weapon? In this case, we have a timer, which restricts like the amount of time that you can, like how fast you can fire, basically. And if you have satisfied that timer, then we let you shoot. And by shooting, we just spawn in a laser. And then there's other systems that are responsible for actually handling the laser movement. So we can get rid of commands, we can get rid of last shot in this other system. We don't need the space sheet anymore, apparently, which is pretty cool. So we can get rid of images and sheets. Because all we're doing in the player movement system now is modifying the rotation and the movement vector. So this is a good place to test some gameplay, make sure that we can still shoot. Looks good to me. Let's make sure we can rotate. We didn't modify any of the collisions or anything, so like all of this other stuff, like lasers colliding with meteors and things like that, should all still work. It's one of the really nice things actually about having like the ECS work like this, because all we're doing here is handling the spawning effectively of these lasers. So nothing about how those lasers behave once they have been spawned has even been touched. None of that logic would have a diff in the get diff, for example. Let's make sure we have everything. Commit. Split out weapon system. And we probably won't, because I don't think there's any upgrades in the original Asteroids. So this weapon system is probably just going to stick around as is. Probably not going to get a lot different. We might be able to simplify it a little bit now that it only handles the weapon stuff, but for now it's just going to live like this. But if we were going to do like upgrades and things like that, for example, this timer could live on the weapon type. The weapon type could be a component on the ship. That would make our query a little bit more complicated. But since we don't have to do all of that configurability, we don't have to do it that way. So movement system, we've got our movement factor. And I don't know that that impacts. I guess the rotation does impact the direction you're moving in. But we could handle that in a different system as well. Deciding if I want to or not. Let's take a look at our, not the UI pack, but the space sheet that we've got here. Do we have anything that looks like it should be a booster? There's some stars here, some explosions. Maybe one of these like things up here in the top corner. I thought these were, it's gonna be really hard for me to show this inside of VS Code. Let's reveal that in Finder. And pull this up. Okay, so like way up here in the corner, we've got some of these like triangle-y looking stuff. I was thinking those would be like searchlights more than anything else. There's a whole list of them here. But that realistically could be like the booster power. I don't really see anything else that makes sense for that to be true. Maybe there's something in one of our other sprite sheets. Is it visible enough is my second question. I also don't know what they're called inside of the sprite sheet, so we're gonna have to figure that out. I'm a productive person. I guess so. How many hours do I work? How many are productive? What do I attribute my productivity to the most? I mean, it's kind of a boring question because, like, I work on the things that I want to work on, right? And I kind of set up my life to do that. And I don't get into like hyper productivity of any kind. I'm not a person who's going to try to like sell you the next big productivity, guru, whatever, who knows what. Not somebody who's like, oh, if you're not, grind setting, then you suck or what, anything like that. So like I kind of work when I feel able to, and I don't work when I don't. And however many hours a week that is however many hours a week that is. Because it turns out that if you don't feel like working, right, in like a regular capacity week to week, like assuming everything else is fine, if you feel tired, then you should go take a nap. And if you feel like working, or rather, I find that scheduling time to work on things or to start things at least is really useful. But yeah, I don't track how many hours I work. So I can't answer that actually. And if I am productive, I attribute it to like taking rest when I need rest, and then coming back and working on things when I feel ready to work on them. And like that's a very vague thing to say because sometimes you just don't feel like working on stuff, but you still need to get some stuff done. And like that's fine too. But as long as the vast majority of the time is like when you're tired, you rest, and when you're able, you work. But yeah, I don't have any answers for like how many hours a week I work. I do think that you only get like 2 hours, maybe 4 if you're having an extremely good day, like 2 to 4 hours of like real hard mental work. So take that for what you will. Like you can still answer email or something if it's low cost for you, but if you're doing like real novel, like stuff you haven't done before, kind of mental work, you only get like 2 to 4 hours of that. All right, so let's figure out which thing this is. Sprite sheet. Oh, there's engines here. Where's the engine? Engine 1, 2, 3, and 4, and 5. Huh, I wonder what those are. There's also fire here. Some numerals. You were saying that you were always productive when you were behind the screen. You were not eating any time. Yeah, I guess if I'm feeling unproductive and I don't strictly need to work at that moment, then I'm not working. Yeah. Like I'm not like, you don't need to be at your peak productivity to get stuff done, right? Like this stream is not necessarily the most productive I could be, if that makes sense, right? Like I'm streaming, I'm talking to y'all. I'm like, I would have had the engine spawned in already if I wasn't answering a question, for example. So it all matters about how you measure productivity too. Like, is the point to be on stream talking to people, like hanging out with the community, answering questions, or is the priority to actually like make asteroids or something like that? Like, if the priority was asteroids, it wouldn't be on stream. Let's put it that way. So let's figure out how to get this engine in. I don't know if these are like actual engines or if these are something else, but we can go to our ship and figure that out. Where do we spawn in the ship? I think it's in lib. So we've got ship bundle. We actually can't do children in a bundle, so it's going to be a little bit awkward. Let's say commands.spawn sprite bundle, maybe. We'll copy this. Sprite bundle texture atlas, right? And then these don't need to be, because that's not a struct, but they do need to be inside of a tuple. And we'll say this is let engine, I don't know, engine fire. I don't know what to call this. Afterburn. This is going to be an ID, not just a thing. So this should just work actually to start off with, and then we can kind of figure it out later. So we're going to add child to the ship. This is only going to add on the very first ship spawn because we do spawn the ship in at least one other place. It's kind of one of the drawbacks of, in my opinion, bundles at the moment. Unless you write a custom command, which is totally valid and works. Unless you write a custom command, it's hard to abstract these kind of spawns. So let's see if that spawns in. It should spawn in like a ship, effectively. Or actually, let's figure it out. I think I spawned it in the exact same place. So they might just be overlapping. Oh, no, there it is. See? So effectively what we have here is one ship with another ship kind of like childed to it. And because we use the same transform, right, it is offset from the original ship. So what we actually want here is probably something like, well, let's go with -10 here for the Y location. I don't know exactly what we're going to need yet, so we do need to figure out what index the other one is. So I've changed the transform and we should get, yeah, so slightly offset to the back now, Y index, or not Y index, Y axis, right? And it's the Y axis relative to the original ship. So it's moved kind of wherever that Y axis is as we rotate. So we don't actually need to do much. You will notice that if we crash, we lose that because we're not spawning it the second time. But now we need to figure out what that index is. I don't remember which of these examples is like the right one to use. Okay, this one doesn't give us the index. So I wrote 2 examples in this examples folder. If you're not familiar with examples, you can put whatever you want into the examples folder. And this is just by Argus. This is just like another Bevy app. It's just a random Bevy app. And I can run this and it shows me, in this case, all of the different individual slices of some texture atlas that we loaded in. That I don't think is what I wanted. I think the other one might be a little bit better for us. I don't remember if I finished these examples or not, honestly. Okay, so we can do this, and I can manually count it every time I hit space, but I don't want to do that either. So I'm going to go into the sheet. I'm going to assume that these are all in order. So it is line number -2, which would make engine 1 69. Nice. So let's go back to lib. We're going to use the 69 index into the engine, run it, and see if that's the one we expect it to be. This may be actually like a physical engine. Yeah, I think it is a physical engine. Which is cool. Like we could build up like a boss ship or something, but it's not really what we want. What else do we have here? I think all these engines are going to be physical engines. Let's try Fire 0, which is going to be 74. Okay, that does look like it's the... It does look like it's the engine fire. It might be reversed, and it might be in the wrong kind of spot. So let's make this like -100. I could put in Bevy Inspector eGUI. You see me like restarting the app a lot right now. I don't necessarily have to do that. There are other options. So I think we need to flip this. I think that we can flip it using this sprite. Fill struct fields. Yeah, okay, we've got flip here. We're gonna put the default in. We can resize it, but we don't need to. So I'm gonna flip Y true. And remember my comma over here. And this won't line it up exactly, but we can figure out where that should be for each. And I assume that we're going to need like a different engine for each of them, honestly. So we're probably going to want to hide this originally too. So let's live with that for now. Let's say this is -30 or something like that. Way not the right number. Say -60. I just want something that's vaguely near the edge of the ship. I don't want it like floating out in space. So like that's fine for us right now. And we can definitely like come back here and change this. But that seems fine for the moment. And we can also do other things too. Like we could apply material meshes to that, or materials to that, shaders to that, make it fade out a little bit stronger, make it flicker a little bit. Okay, so that's all there. We also need visibility now. And I'm gonna make this hidden. And then I want to tag it as player engine. Engine fire, player engine fire. I really don't know what to call this, to be perfectly honest. So player engine fire, let's put that in ship, I think. Like, I do think that eventually we're going to move all of that into ship. I'm just kind of like figuring out what the right things to do here are at the moment. So we're going to have a player engine fire struct. That struct is going to be a component. So now that can insert where we put it over here. We do need to import it. I didn't make it public in the other file. So player engine fire, right? That comes from ship. So now this thing that is sitting on the edge of our ship positioned in the right spot attached to the ship is no longer visible and has a component we can query for. So if we go back to controls, what I want to do is think about how we want to turn this on. So basically, whenever this arrow up is pressed, we want the engine to fire. Which basically means for us at the current moment, turning the visibility on and off. So I think that we can just do that in a completely separate system. So we'll do engine fire, and we will query for visibility and mute visibility. And we'll filter for the player engine fire. We do need the keyboard input. And this is the part where it's kind of like, it would be nice to have Leafwing input, because right now what we're doing is arbitrary button presses, and there aren't that many arbitrary button presses in Asteroids. So it's not that big of a deal, but the more we split out these systems, the more it's going to be an issue. So especially if we ever add like controller support or something like that, right? So you don't really want to be using button input for larger projects. You want to be using like actions, right? Like thrust, like action thrust instead of button input arrow up. So we've got engine fire for, we'll call this thrust in query. We're going to iter mute here. This will be mute. Our query needs to be mute as well if we do that. Let's do keyboard input. If I can type, wow. Keyboard input dot pressed. What is it? Keycode dot spacebar. I feel like in my brain, I have two ideas here. One is that when we hit space, if we do it this way, we will just be setting them all to, let's call this visibility. This will just be setting them every frame, which is fine. Visibility, nope, not view, visibility, visible. So we can do this, it'll be fine. And then we would have to also have the other way. So this would have to be hidden. And I think we need to dereference these. They don't need to be mutable, maybe? No, they do. So what we're getting from the query is we're iterating mutably over stuff. We store that in this variable. We want to make sure that we can mutate it. We want to dereference into the value inside of it. And then set that, because specifically this comes back as a capital M mute, which has visibility inside of it. So we need to dereference to the actual visibility value and then change that value. So if we put this engine fire in, this can just run whenever, right? But we really only want it to run if it's in the playing state. So if we start here, Let's make this a little bit bigger. So if we have, oh, we don't have something that we need. So the bundle has duplicate components. Bevy sprite bundle, texture atlas, view visibility. Player fire, texture atlas. I don't see anything. It unfortunately, my terminal chopped off the output, so I'm going to run it again. Encountered a panic when applying buffers for start game. That's interesting. That means we aren't doing something correctly in start game, which is this system that we just modified. The bundle, sprite bundle, texture atlas, visibility, player engine fire has duplicate components visibility. Oh, because sprite bundle. Okay, yeah. I want to say sprite bundle is the thing with visibility. So if we comment out default and we fill struct fields, yeah. So this visibility here is where we're going to set hidden. And if you're unfamiliar with Bevy, bundles are basically like collections of components. So it's the same thing as adding like an individual component. So this sprite bundle is the same thing as if we had added a transform and a texture and a sprite and a visibility and a texture atlas and a player engine fire. So we run that. Oh, I used the wrong key, didn't I? I set it on space. So you can see that the engine is actually firing. Unfortunately, I set it on space, and none of you told me. I set it on space, which means that it is going when we fire our laser, not when we move forward. Another downside of using button input instead of something else, I probably would have noticed sooner if we were using actions and not button keys. So new game, we've got our ship. Now when we move forward, we have a system controlling the visibility of that. And you can tell that it is applying, right? Is it the best looking thing in the world? No. But we're using like a set of additional, sprites. Or like pre-packaged sprites, right? So I'm not too worried about it. But if I tap it, you can see that we're kind of like stagger boosting. And I'm pretty okay with that in general. It's not, like I said, the most beautiful thing. But it does do what we wanted it to do. And we could always change the visuals later. Huge fan of blocking stuff out. Now, I don't know if this works for the other ships. It may be in the wrong spot. So let's git commit what are we going to call this? Engine afterburn enabled for one ship. Well, let's cargo run it. Oh no, we're going to crash. Okay. So I think these ships might be in the same place. It actually works for this one too. I know that once we crash, we don't get it anymore. So we do need to make sure that we do that next. So for lib, we have this engine fire component that we're adding. And then we add child here. So when do we spawn a ship? I think that's for the ship destroyed events. Yeah, player ship destroyed event handler inside of ship. So ship destroyed, spawner reset. Here's our bundle. This is where we're going to stick this. It's starting to get a little bit complicated to have extra stuff spawning in here. And as you can see, it's already pretty easy to like forget something. Agile. Agile. So that should work for when we respawn now. It's looking great. Jumped in late. What kind of UI lab are you using for the menu? This is just Bevy UI. Bevy UI is not known for being the best or most usable UI solution in the world. And I think everybody knows that at this point. There's things that are, and then we have some other issue. I think everybody knows that works on Bevy and, wants it to be better. But it is pretty possible to build like nice looking things. It just takes a little bit more elbow grease. So that works for us. Nice, haven't used it yet, should give it a go. You haven't used Bevy UI yet, or you haven't used Bevy, like the game engine yet? One thing I find annoying on my potato PC is the need for waiting between recompiling. Is there a way to hot reload code? There's no way to hot reload code, but there's two suggestions. Bevy. Why is this white? Yada, 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 Mac OS, creating a Bevy project, perf optimizations, enable fast compiles. So if you go to this section in Bevy, in the docs, there's a dynamic linking feature, which very much reduces the amount of time that compiles will take because it takes everything and throws it into a shared library for like what is Bevy, right? So this can help a lot. Using a different linker can help a lot, but the linker I would have pointed you at, which would be mold or sold, which would be the Mac OS version. Sold is deprecated now, as of very recently, like a couple weeks ago, max, like 2 weeks. But basically the Mac OS linker suddenly got more performant. They put a bunch of work into it. So that should be less of an issue moving forward. And then the other option is, depending on what you're doing, you can use something like Bevy Inspector eGUI, which will pop up this world inspector, or whatever kind of inspector you want for whatever cases you want. You can build out like full entire UI with it if you really want to. And this will allow you to change a lot of the properties for any entity in the system very quickly and dynamically and right inside. So depending on what you're doing, you don't need to recompile. You could do it at runtime effectively, which is the same thing the editor is going to do in the future. You could do dynamic linking, which should speed up your development time. And then like worst case scenario is always, recompile. I have that enabled, still need to wait like 15 to 20 seconds between compiles. Yeah, I would say if you have dynamic linking enabled and you have all the other stuff enabled and you're still having like performance compilation issues and your PC just may not be super great for compiling code in general. Like that's totally possible and viable. I would look into things like Bevy Inspector, eGUI. And like, depending on what you are modifying, that can help out a lot. So for example, when I was doing the afterburn, right? When I was just inserting the afterburn, if I had Bevy Inspector eGUI, I could have just stuck my cursor in there, moved it back and forth, found the value, and then put the value into the source code file. And that would mean that I didn't need to recompile 5 times to figure out what the right position for the afterburn was. But yeah, that's kind of my suggestion. I will say if you're planning on doing Rust long term, having a more powerful computer is always better. Because in kind of like a difference from other languages, Rust does a lot of work at compile time. Whereas like if you're used to using, I don't know, like JavaScript or something, you might not be used to even work happening at compile time. The other thing you can do is Rust build performance. Hopefully this will give me the right, yeah. So there is a Rust performance book that you can look up. And this will also have abilities to see where like you're spending compile time, whether it's the linker or whether it's a specific crate. If you have a very large project and you have like one super massive crate, you could split that up into different crates, things like that. So there's a lot of suggestions in here for building and compiling and things like that. Well, that's a trade-off. Can't have fast compile times with memory safety guarantees. Yeah, that's kind of what I was getting at, right? Like the Rust compiler is doing like real work. And you can see that between doing like a dev build and a production build, right? I forget what I was going to write in that Git message, but if we do cargo run, right? Cargo run is going to do a dev build, and dev builds are pretty fast because it's incremental, because it's not doing many performance optimizations. If we do cargo run like release, it'll take a little longer. It will compile everything more thoroughly. It will do performance optimizations that otherwise wouldn't have happened, which will make the game run faster, but it makes the development cycle slower. So like, yeah, there is definitely a trade-off between like how much work you want done at compile time and what that's getting you. Love your Rust content. Starting out learning Bevy, will definitely rewatch some of the video streams when you have some time. Nice. Feel free to leave comments on them. I do check them out. Cool. So I think we're good on the afterburn, right? Not sure if you've mentioned, but maybe crane lift could help out compile times in the future. Yeah, so crane lift is like possible to use. The other thing I'll mention is that like different platforms have different performance considerations. Crane lift Rust. So you can technically use crane lift today. It is available as an experimental thing inside of the Rust C distribution, I believe. I don't really use it currently. And that's not really for any strong reason. It is a little bit earlier than other things. It is kind of a long-term project. But yeah, crane lift might help you out as well. Okay, so do I feel like we did the input refactoring? We did do the afterburn, so afterburn is good. Do we want to do leaf wing? We could do leaf wing. I don't know that it gives us much in terms of benefits for this. because we kind of have like left, right, shoot, and thrust, right? So I don't think it actually gains us anything. It does gain us this like little keyboard input would be better. This engine fire system is running every frame, so it's checking and setting visibility every frame. We could modify that. We could have some local state that decides whether it should change or not. Not too concerned about it. This isn't a performance intensive game. And the check here is really tiny. I don't feel a strong need to split out rotation. The only reason I could think of splitting out rotation and what that would be useful for at this point in the game is if we wanted to have UFOs that rotated around the player or did different things or moved in different directions. But we don't have that, and I don't plan on implementing that, so I don't think I'm going to pull it out. So I think I'm happy with this for now. I'm going to call our... I will mention Leafwing on stream because Leafwing is, when I'm working on my own projects, my preferred way to do input management. And the idea is basically like you add the input plugin, you add the input plugin manager, just like any other plugin. You define the actions that you want to handle. So in this case, it's run and jump. Let's make this a little bigger. So you define the actions that you want to handle as an enum. In this case, it's run and jump. For us, it would be like thrust, turn, and fire. And then you insert this input manager map, which if I scroll to the right, you can see that the jump action can be triggered by space, or it could be triggered by gamepad X or something like that. So then in your systems, instead of querying for keyboard input, you would query for this action state action. And it's kind of like a nice pane of glass between your inputs and what your code actually does. So in your code, you can do, oh, the user wants to fire right now. Should I let them? Rather than the user pressed space. What does that mean? Refactored on stream, no Leafwing today. So the next thing is the live system. So we are counting lives at the current moment. If our ship hits a meteor, it will despawn. When it despawns, we fire an event and we do this checked subtraction and we get this game over effectively. We kind of need to have a game over state. So maybe we start by adding that and then we add the UI on top of it. How to solve input lag? That is a very generic question. Do you mean like... I guess like I can't answer that without knowing more about like the context, I guess. I would say input lag can be generated from a number of different like methods, right? It can kind of be anything from your controller to the way the game handles input and what's happening on your computer. In your game, your input handling should be running every frame, for example. If it's not, if you have like you know, run if in state, whatever, or like run if like player is pressing key or something like that, you can be constructing your own input lag, which is not a good idea. Okay, so lives, we've got lives 3. This is a resource that got sort of inserted and handled here. For game over, we need to add a game over state, right? Because that's probably what we're going to do at the end. Do we want to send people back to the menu? Let's just send people back to the menu for now. Let's not even add another state. So we're going to need next state here, which I always forget. So I'm just going to use rip grep and copy it in. For the life of me, I cannot remember what this looks like whenever I write it. It is a mutable resource. We get the next state with a type argument of game state, and that gives us the ability to change the next state effectively. So next state, set, game state, menu. And when we run out of lives, we should hit the main menu then. Can you get input actions in between frames? I guess if you were running outside of Bevy, you could do that. I know that Overwatch does some like really fancy like run input, and not necessarily like a separate thread, but like they run input as a separate thing and then kind of like shove it into frames and send it. But I'm not too familiar with how they do that. So let's cargo run here. And when we run out of lives, we should get this main menu back. So let me crash. I can't even hit the meteor with the ship. And then one more, maybe one more. Yeah. So now what's happening on screen? The meteor is still running, right? The ship is still sitting there in the middle of the screen. It's kind of interesting to see the meteor like running around, if that makes sense. I kind of like the idea of the meteors continuing to operate once we get to the main menu. So I think I'm going to include that. I have no idea what's going to happen when we hit new game here, right? We didn't put in any logic for respawning. So I think right now all that's happening is that every time we start the new game, nothing got cleared. So in this case, we're just spawning in new ships. And the new meteor is spawning at spawn, I think. So this is not great, as you could probably guess. Better than blank background? Yeah, I agree. So we've got some like, when we start a new game, we need to erase some stuff to be able to start the new game stuff going on, which totally expected. And you can see that we actually have an error here. As we got more and more player components, our systems only expect one, but the game didn't crash. So this is coming from controls, right? In controls, we have this warning here. This warning is the query for the transform with a player. We're only expecting one. And if we get more, we're basically logging out an error message and not doing anything. This is kind of like an error state for the game. We have options for what to do here. I decided to not panic the game. So we were able to see more and more ships spawning in, which I like personally because it means that we get to do more development and see how things work a little bit more before the game actually like full crashes. Because full crashing is not fun, right? Like the game crashed and now you got to read an error message is not, I don't know. It's not fun for players. It's not fun for developers. It's just not fun in general. So I try to only unwrap like I am here, if something really truly needs to be there. So lives, we're going into the game state menu. So we either do fixes for the like level reset, or we visualize the lives left. I feel like I want to visualize the lives left. So we need that ship icon. So in here, there's a very small ship. There's a couple of them, one for each of the different types, I think, actually. So we'll want to get this off the ship type, probably, the player ship type. Is this called player life, player ship? There's player ships, but there isn't icons. I don't know what these are going to be called. Wing yellow, laser green, fire gun, cockpit cursor, beam. There is another way that I can figure it out. I chose to not take all of the individual player life. Oh, are they meant to be lives? Oh, that's very cool, actually. I didn't know that they were meant to be lives. So player life 1 blue. I think we only have blue in the game right now. So we'll need this one, and this one. So 88, 92, and 96. Ship. Instead of that, we're going to get Life Atlas Index. And I think I said, what, 188, 192, and 196? So this just gives us the icon that we need to use to show each ship life. It probably comes with the sprite sheet. Yeah, I didn't generate the XML. So this is, just to be absolutely clear about what we're doing here. The sprite sheet here is generated by Kenny. Kenny produces a wide array of very usable, very nice, like basic sprites. 3D, 2D, you know, a whole bunch of stuff. There's like googly eyes for no reason because they're fun. But like Kenny produces a lot of assets that you can use to build out the mechanics of a game without having to worry about doing too much of the art asset yourself. So for things like this, for Asteroids, for, you know, some workshop that I do or whatever, I always use Kenny's stuff. You can, there's a donate button, but you can also go to itch.io and just like buy it. So this is actually what I have on disk. It's basically everything Kenny produces. And I just pay for it. And they send out updates and I give them some money. Very, very, very useful. Highly suggested. Now, the way those get to us is as like a whole bunch of folders. Let's see if I can pull it up here. Yeah, I think I can show this. Okay, so what do we get here? Oh, did I mess that up? I think I did. the wrong folder. It's so, like some random place on my machine is the problem. Let's see. Kenny, game, all in one. Open a new tab. Let's pull this over here. Okay, so what we get here is a couple of folders, 2D, 3D assets, some archives, some audio, some other stuff. Inside of 2D assets, there's a whole bunch of folders here. And you can see that like this platformer is a 1-bit platformer. It's got, you know, like a tile map and a tile sheet and a whole bunch of stuff. And like the specifics aren't necessarily important. But if you click on any of the stuff for any of the packs and whatnot, it's likely that you end up with one of these sprite sheets. In this case, it's just like a bunch of beards and then an XML file. And I don't know what tool they use to create this XML file, but we do get this XML file because of the way these sprite sheets are packed. So Bevy by default, if you use something like Bevy Asset Loader, lets you load in a sprite sheet that is set up in a grid, right? So a perfect grid. So like a 24 by 24 pixel grid for, you know, hundreds of objects or whatever. This is not a grid. This is just like random rectangles like drawn into a sprite sheet. So it's like much tighter packed. It's a more production style of sprite sheet because you're not wasting as much space. So then this XML sheet is generated by some piece of software. I actually don't know what they use. At the root is a texture atlas node, and then there's a bunch of subtexture nodes. This comes with name, the position in the sprite sheet, and how big the rectangle is. And we can read this XML file in Bevy, and then create our own texture atlas layout with these coordinates. So that is this Kenny assets folder or file. Sam in chat is saying, for anyone wanting to do this themselves with their own sprite sheets, Texture Packer is a great piece of software. I personally have maybe used Texture Packer. I don't remember which one that is. Oh, see, I've already clicked on it. Yeah, I think I used this one for something. It's kind of awkward in general. Like before Bevy had assets, I think I tried to use this, and this was trying to do everything in this like packed format. And there was no real nice way to pull a packed format in. So I had to do like grids and things like that. But basically you can create your own asset loader in Bevy. So for me, what I've done is created an asset loader specifically for these Kenny style XML sprite sheets. So our asset is Kenny sprite sheet asset, and our loader is a Kenny sprite sheet asset loader. Both of those are things I created. You can see the subtexture mirrored as a struct inside of our Rust code. This is the asset. The asset holds the vec of subtextures, just in case you want to access the indexes by name. I forgot I did that, actually. That could have been useful. Whoops. It also holds like a handle to the image that is the actual PNG. And then it holds the texture atlas layout as a handle, which is the thing that we're using to like, when we pick an index, which rectangle inside of the sprite sheet should it be looking for to render the sprite. And you have to implement asset loader for this loader. The code isn't particularly, I don't know. I would say this is the first time I wrote a custom asset loader, so I wouldn't necessarily use it as like a, this is the way you should do it, but it does work, right? It's a working asset loader. So it may give you some information, but I wouldn't necessarily say it's like the way to do it, if that makes sense. You get this load context, which gives you the asset path. I do this thing where I swap the extension with a PNG. So If we look back at the assets, we get, you know, spacesheet.png and spacesheet.xml. I'm loading .xml. So I swap it out with .png and we get the handle to the image using load. We need to load it in directly because we need like the coordinates of the total sprite sheet, the PNG. And we load it in like regularly, which should only, as I understand it, load once. But we get a handle to that image as well because we need the handle for later. We need to keep it around or Bevy will unload it. So we get that image, right? It comes in, the PNG comes in as a capital I image. That allows us to get the size in F32s of the width and the height of the total image. XML reading is not super interesting. It's super messy. I don't like XML. I wish that these came in a different format, but such is life. So I use RO XML tree as a very simple XML parser. We construct the sprite sheet dimensions, X and Y, from what we just talked about. We start building a texture layout with the dimensions. And for every subtexture we pull in from this XML parsing, we create a new texture with that rectangle for that index. So what we end up with at the end of the day is this Kenny sprite sheet asset, which is just an asset, right? So it's got the subtextures, all of them. It's got the sprite sheet handle for the image, and it's got the texture atlas layout. So if we go to lib and we look at the assets that we're pulling in our queries, we're pulling in images, which I'll mention in a second. And we're pulling in the database of all of the Kenny sprite sheet assets that we've loaded. If I go to my assets file, this is Bevy asset loader. Works exactly the same as asset server, like : load. Same thing from an asset loading perspective. So in this case, I'm saying we have this space sheet. I'm looking for spacesheet.xml in our assets folder. This is going to be a handle to a Kenny sprite sheet asset, which is my asset type. Bevy asset loader loads that in for us. So when the start game system runs for the first time, we know that this sprite sheet is loaded. So images will give us the handle ID, and sheets will give us the sheet asset. So when we do this, this is the key here. For the sheets database, the sprite sheet database for all these Kenny assets, we grab the, handle ID for that, and we get the Kenny sprite sheet asset. So now what we have is this struct that we defined. We've got the subtextures, we've got the sheet handle, and we've got the layout handle. So when we're spawning stuff in, we can say, okay, the texture is going to be that PNG, the handle to the image. The texture atlas is going to use some index, and the layout we're using to define what rectangle that index looks for is that texture atlas layout that we built up. So a little bit more convoluted than just like loading a PNG or whatever. If we go and look at assets, you can see that I also have some individual images here. If I can get this like Kenny assets loader to be, like production ready enough, then I'm going to release it as a plugin, like Bevy plugin Kenny asset loader or something like that. Because I think it would be useful for more people. And writing this over and over is not particularly, fun. But again, I don't know if this is the right way to do everything. It's just kind of like the first thing. I wrote this on a plane, so I didn't really have access to much. But yeah, so that's how we're doing assets. That's the XML file. That's the PNG file. That's how they work. That's why they work. I totally forgot what we were doing before that. Lives, right. Okay, so ship, lives. Player ship type. So we're pulling the indices out here. the XML file, because we do the XML file in order when we parse the XML file to create that texture atlas layout, each of these is going to be like, this is going to be index 0, and this is going to be index 1, and this is going to be index 2, and so on. So if we have the lives, player life, right, and we're at line 190, we subtract 1 because there's a root, and we subtract 1 because we're 0 indexed and not 1 indexed. So this would be index 188. So what, 188, 192, and 196. 28, 92, 96. Okay, so we've got our indices correct. We do need to have some kind of system for spawning, like, the amount of lives that are left. I don't know how I want to do that exactly. I tend to have this, like, UI.rs file in all my projects. I think I want to potentially do this differently. I think lives is gonna keep that. So we have a lives plugin, right? Life plugin. Life plugin doesn't need a lot of this complexity. We're not going to need a texture slicer. We don't need 9-slice scaling. We're going to need an image bundle. So I think I'm just going to copy this system in at the moment. And then lives, and we will have, I don't know, like render lives, maybe? And this will be some stuff. Let's not do with children. We're going to have a node bundle at the top. I don't know that it needs to be max height, max width. We don't need to center because we're probably going to keep it on the left. So I think we're just going to keep everything as the default for the moment. I don't know that we actually need anything here if we're just going to keep everything as default, but so we're spawning a node bundle, right? And this is going to be like our life container. And this will happen later, probably. So we don't need image scale mode. We only need the image. We don't need this. We don't need that. This is going to be like commands.spawn at some point. I know this is super messy, but this is literally how I do. When I write code, this is how I write code, and then I hit save and it reformats everything. I'm not saying that everybody should do it that way, but it is the way that I really write code. Okay, so image bundle. This is probably going to be self-selected size. Let's get rid of these justifies. Border, you can comment out border for the moment. It's my way too. Once you get an auto formatter going, it's really hard to look back and be like, wow, I lived without that. So I think when the game starts, we'll want this to spawn. And then we'll have to... Trying to think, do we want to listen to the events and modify this? I think we just want to pay attention to the resource. I think all we're going to do here is res lives, I think. Did we call it lives? Yeah. And then I think lives dot is changed. So if it hasn't changed, do nothing. And this is like an expected thing that should happen. And then I don't know that we want to spawn in here necessarily yet. We've got to match the number of image bundles to the number of hearts. We can't go up in life count yet. So maybe we create a local heart entities, right? And we just keep those around. Feels a little weird. They do need to be ordered though. So like we do need to like despawn the one at the end, if that makes sense. So I do think we need to hold this around. For local state, this does need to be local. And I guess this is mutable. I'm trying to think of a way where we can handle that in a different way. We could have a component instead that has the index for the heart. That feels a little bit better. Because then the component index should match up with the lives, right? So struct life. I don't know. What do we call that? Component derive component life what? Life sprite? Why not? Life sprite. Oh, life index. We're going to do life index. I'm going to leave a note here for life index is the that's not going to be helpful next time I see it. Okay, so we've got life index. That's going to be the index of the heart or like the ship life on screen. We've got render lives. Render lives is going to have to respond to that resource and render the appropriate number of lives. I think just adding children and removing children would work for us. So let's say this node bundle is going to be life container, which we don't have a struct for. It's going to be the same thing. Derive component, struct, life container. So life container, we are going to have to query for in some way. So maybe we... I'm struggling a little bit with the idea of like we're going to need to bootstrap this a little bit and also modify it at runtime. So I think I'm going to start doing it like this. I'm going to spawn this in here, right? Life container is this, and then we don't need to worry about it. We just have the life container all the time, and this gets spawned. Add systems. On enter. Game state playing. So this should spawn when we go into the playing state. Then we need also probably a on exit playing. That is not how you type that. On exit game state playing. We'll do remove life UI. This is when it comes in. We need the life container. So query is going to be a query for entity with life container. And this is going to be commands or for entity in query, which is only going to be the one, which is fine. Commands.spawn is going to be commands.ent. Oh, I got rid of commands, didn't I? New commands. Commands.entity entity.despawn recursive. And that should just remove everything whenever we stop playing. Hey, what are we doing here? We're doing asteroids. Right now we're doing the life system. So showing how many lives you have left and that kind of thing. So this is going to be render lives. Why does that wrong? Remove life UI. Commands. Query with life container entity. Is this an Argus thing again? No, there is actually an issue here. Okay. I probably didn't specify the constraint. Oh, add systems. That makes sense. I thought I disabled Argus already, but it still seems to be conflicting with Rust Analyzer, which is kind of annoying. So we've got lives. We've got spawn life UI, which spawns that container. We probably also want to spawn in like the right number here, but let's do let container equals this, and then for life and lives, actually not for life and lives, because this is a count. Lives dot 0, right? So it's going to be 0 dot dot lives dot 0. That looks weird. And that's the U size, and we don't really care about which integer this is. I don't know that we care about what integer that is yet. So commands.spawn, we're going to spawn in this image bundle. We need images. I think we also need the sprite sheet, right? Because this is using glass panel, but we want to use the texture atlas. So let's go grab that from lib, probably. We need this, and we need this. Yada, yada, yada. Import that. You hate that in Rust, x.0, x.2. So those are just tuple positions. You don't need to use them necessarily. For example, Bevy has something called deref and deref mute derives that you can use to get rid of that. But yeah, like resource doesn't necessarily need to be a tuple, right? And if you've got something in x.2, for example, there are usually other options, right? Like if you've got a 3-element tuple, you could just make that a struct and it's the same thing. And then you can do field access. Okay, so lives, image, not panel glass, space sheet, dot sheet. So like this, right? This is a struct. Could have been a tuple, isn't a tuple. I think instead of a for loop, maybe we do into iter dot map index, which we aren't going to use. I think we can then, we could map over this again. Or we could do this inside. So we have two options here. I think the way that I'm going to go right now is with children. So I'm going to do, instead of having this container outside, what I'm going to do is dot with children. This is going to have a builder inside of it, whose name is Bob. And this is not going to be returned, so we don't get all of that. And then this is not going to be entities. This can go back to being our loop, which some people find easier to read. And then builder isn't being used, commands is being used. So we need to swap that out. We're not using index ever still. So we end up with this container that we are then creating children inside of. And then our for loop just gets to live inside of here and we don't need to worry about anything. So builder spawn image bundle. Is that what I want? I think that's what I want. Reader, ship bundle. This is a sprite bundle with a texture. I think the image bundle is probably what we want. I think we want image bundle and texture atlas, if I remember correctly. This changed in Bevy 0.13. So I think we do image bundle. So instead of doing like texture atlas bundle, you do the image bundle, which has the style sheet, or not the style sheet, the sprite sheet. And then you do the texture atlas. And the ship type needs to come from somewhere, which is just player ship type, right? So query query player ship type. And realistically, this should only exist once, again, which we've done before. I think it's in the collision. No, it's in controls. Player movement system, movement factor, player ship type with player. This is what I want. Basically, I want to say we want the ship. There should only be one. If there is more than one, that is kind of like fine, except for the fact that we can't run this if there is more than one. Only expected one player ship type component. Cool. So then we get our space sheet, we get our commands. This is a node bundle. It's kind of like a div if you're familiar with web stuff. This is the children of that div. We're looping over and spawning in a number of, I guess this should be called ship type, shouldn't it? Ship type. Spawning in a bunch of stuff. This is going to be Life Atlas Index. So at this point, we should be able to, when we start up, see like the initial hearts. It may not look right, but we should have something running at this point. Ah, okay. So when we spawn our menu, there are 3 ship types, which makes sense. So we need to constrain our query here. To with player. And I'm actually curious now because we're running that through an event, right? So I don't know that we're even going to be able to actually see that soon enough. Yeah. So we're actually not going to be able to query for this because the way that we start the game is we have a menu and we're firing an event to choose the ship, at which point we spawn in that ship. But the player hasn't really chosen their ship yet, right? So if we want to spawn the life UI and we want to spawn it with the right player ship, we kind of have to do it after that. So the question is, what do we want to do? Do we want to have a resource that contains the player's ship type choice? If we go back and we look at the menu, actually this should be in ship, right? Choose ship event. Yada, yada, yada. This is starting to be a decent amount of code. Choose ship event. Oh, that's not how you spell that. Choose ship event, lib, and choose ship. So I think lib is what we want because lib is where we read that event. This is on enter, on exit for the choose ship game state. And we're running setup UI on, not that UI, this UI. We're running setup UI when we enter playing. And in lib, we do start game also when we enter playing. If we look at main. So on enter playing, we start game, and on enter playing, we also try to read the thing we spawned in start game. So how do we want to order this? Or do we want to order this is kind of the question. So there's a number of different things we can do, a number of different approaches we can take, right? We can spawn this UI in like way early, right? We don't need to spawn in all the lives. We can spawn in just the container, and then we can let the actual update system handle the rendering, which is going to have to do anyway, quite honestly. So I think that's what we're going to do instead. We're going to disconnect these from needing to be ordered rather than try to like keep them ordered. So we have this life container, right? And we're going to get rid of with children here. So all we do in the startup is we spawn life container. All we do in the remove is we remove everything in the life container. And then render lives is going to be responsible for life container. Let's do life container is a query for the entity with life container. And this has to exist, so we're going to solo it. So let container ID equals life container dot single mute or single. I think we don't need mute here because we're dealing with entities. And then commands dot entity container ID. And then we'll add children to this effectively over and over. Oh, that's command, not commands. So we're going to take sheets and player query and probably also lives and images away from the spawn, which makes sense. We're going to stick them down here. Some of them are duplicates now, so we can get rid of them. And then this and this need to come down too. So this gets super simple for spawning the original container. And then here is where we expect to have one player. We expect to have changing lives, which I'm going to remove because that's a performance optimization and we don't have it working yet. We have space sheet and we've got container ID. I think this is going to go into this loop at some point. Do we need to query for each of these hearts to make sure they exist? So this is where labeling them with the index comes in. We have like, let's say a set of 5 hearts, right? And the player loses a life. We need to despawn the 5th heart specifically. We might be able to handle that via an event now that I think about it. But we're reacting to the resource currently, so I'm going to stick with that mental model. So when this resource goes up or down, if it's at 5 or 6 or whatever, if it goes up to 7, then we need to spawn in something new. If it's down to 4, we need to despawn some things. So we do need these to be indexed. Which we did here. So we'll pull this in. This is where we'll spawn our indexes. This will be index. And then we need to query for them, I think. So let's see. Life sprite query is going to be a query for, we're going to need the life index for sure. So we'll get the life index. We're going to need, I guess, the entity, which I kind of in my head like having at the front. So I'm going to move it here. So we're going to query for all the entity IDs that have a life index on them, which is just going to be our ship life hearts. At this point, we can iterate over this and see which ones should exist and shouldn't exist, and then spawn or despawn them. So for index, let's not do with children here. So let's comment this out for now, because we're just doing a loop. This is commands.spawn at the moment. So for index and 0.lives, so we'll have an iteration for each of the lives. We need to figure out if the life is currently shown. And should the life be shown? So I think we'll do the removal as a second loop, right? Because that makes sense to do here. So for remove unused lives, this is going to definitely run for us, but the increase won't necessarily. So for entity index in life sprite query, and this doesn't need to be mutable because we have the entity ID. Let's get rid of these commented outlines. For entity and index in life sprite query, if index.0, so we have the offsets here, which is a little bit annoying. We'll have like a life count of 3, right, for the resource. Means we have a max index of 2 because it's 0 indexed. So if the indexes should match. So if we're at the second one, which is the third life, so if index is greater than or equal to lives.0, commands.entity, entity, despawn, recursive. So this should remove anything that was spawned that is greater than the life index that we're supposed to have. Which means now we need to just spawn the ones that should exist. So if, I'm going to do a little bit of optimization here. If life's, we've got life sprite query, .iter.find, and this is going to be entity and index, or do life index, just to not conflict. So we've got entity and life index. We're going to throw away entity. We don't need it for now. We're only going to do a find on life index. These aren't necessarily going to come in ordered in the query, which is why we need to do this. We could sort them or whatever. I'm just choosing not to do that kind of thing right now. So life sprite query iter find, and we're going to find something where index equals life index. And we're going to say if I guess find is the wrong thing, right? I always do this. So I find and I do like is some. And really we need this to be any. So if anything in this query is an index that already exists, I don't want to break, I want to continue. Life already exists on screen and should continue. This needs to be what? Life index.0. So for the indices that we have, so for the life count that we have, if we have a sprite that has that index, so if it's life 0 or life 1 or life whatever, and it already exists, then it should exist, and then we can just continue with the next loop. Otherwise, we need to spawn one in. Is that accurate? I think it is. I think if we're iterating, we need to spawn one. And this needs to be spawned as a child of. So this is going to be the, what? The next life. We're going to get this as an ID. I think this is going to create some ordering issues, but we'll see. Commands.entity container ID, which is the container we're going to put everything in. We're going to add child with the next life that we just created. So that should be good enough. This needs to run in the update phase of game state playing. Run if in state game state playing. That actually could go up here because these both need to do this. So we'll leave these both up here. And then we'll cargo run and see our program crash. I don't know. You know how it goes. Okay, so this, and then we see 3 little things in the top left. We need to get rid of one here. Come on. Okay, let's not hit it in the middle of the screen because then we'll get game over. Cool. So we hit, we remove, we hit, we remove, and we hit. Now, the only downside here is I'm doing my math wrong somewhere. Because technically here, when we read these events, when we hit 0, we should move to the next state, right? if lives I think that's how that needs to work. So let's run this again. We should have 3 lives now that I've fixed the lives logic. So we spawn in with something, huzzah. We get 3 in the top left, which I was just going to literally point to, which I know you can't see. And we get -1, -2, and if I can hit this before it goes off screen, -3, and our game is over. Not super exciting, not super intense, but we're now showing the tracked lives that we were actually showing before, which is great. So lives are shown on screen. Done. I know there was a lot of like writing code directly. If anybody has any questions about what we just wrote and why it works and how it works, do leave them in chat, because I know that I just kind of spent some time just kind of like in my own head writing that. But basically what we've done is we've got an initialization, a removal, and a actively rendering live system. So when we jump into playing our game, the container that we're going to put these hearts in spawns. When we leave playing our game, when we have a game over, that container despawns and takes everything with it if there's anything left. When we're rendering lives, we take the number of lives that are left and we determine whether they should be or should not be rendered and render them appropriately. This involves spawning and unspawning stuff. If we were only going to let them ever have 3 lives, for example, we could have in our original container spawned in 3 lives and never touched it again. And then we could toggle them visibility wise or do whatever. But I chose to write this in a way that is dynamic so that we can have as many lives as we want. So let's make that true. And let's say there are 30 lives here. Let's start a new game, pick a ship, and now we have 30 lives. I'm not going to sit here and destroy them all, but like, this is one of the really cool things about the way that Bevy works, where if you get it to work and you get it to work in this kind of like ECS pattern way, then it doesn't matter how many lives we have. The only thing that would really matter is if they went off the screen to the right, right? So if we had, I don't know, 50 lives here, something. I don't know how many is going to get us off the screen. Let's say 300 lives. 300 is probably not going to wrap. Yeah, so it just kind of goes off the screen to the right there. I don't know if that's what we would want if we had 300 lives, if we let people do that. Again, this code base originally was forked off a code base that I built on a plane. I think I'm going to take the other one in kind of like a roguelite direction. So it could have this kind of like dynamic amount of lives that you have available. And showing all of that on screen, you know, may or may not be appropriate. You probably end up wanting like a number of lives if you have 300 rather than showing them all. Let's see. Node bundle default. I'm curious right now. Style. This is going to be default. This is going to be style. We'll stick default in here as well. And then We'll fix it when the player hits 300. Yeah, exactly. Flex wrap. Flex wrap. Wrap. So flex should be the default, and that should have been the fix for rendering all of the lives, which, as you can see, makes the game very playable. Oh no, we lost a life. At least we're able to see that. But yeah, so, I mean, completely unreasonable in terms of like how much of the screen this is blocking, but look at how this flows if we make it larger, right? If I do it full screen, we get fewer rows. So theoretically, if this was meant to be played on full screen, our layout now doesn't have to change between, like, I don't know, when we ship it to an iPhone or not. As long as we don't let them have 300 lives. That's actually hilarious. So let me undo this. Actually, I can do this much faster. Just make sure that that was all I did. Cool. Git stash. And we're back to where we were. Okay, so we're showing lives. Now, the only thing that we really have that is an issue is that the game can't restart. So if we go cargo run and we lose our 3 lives, like the game stops. We need to not have that ship respawn, or we need to despawn it. And here, if we hit new game, we lose immediately for a variety of reasons. One is because we're spawning an additional ship. And 2 is because the meteor spawns at 0, 0. So I think I usually have like a reset system for that kind of thing. Something that just kind of you know, resets anything that needs to be reset. I think the only thing we need to really do is in game over, I don't want to have a ship around. So the ship gets destroyed by an event, right? So ship destroyed, right? And right now we are removing the life and immediately spawning. I should make a separate game state for what? We are removing the life and we are immediately trying to spawn a new ship. I do think that this is going to be a little bit more complicated, because the other thing that we also need to fix is when we spawn, we do need to wait to see if there's a meteor at 0, 0, because if there is a meteor at 0, 0, our ship will just keep getting destroyed and destroyed and destroyed, and it actually locks the game up. So thinking about that, I think that that is actually going to be for maybe next stream, because that'll be a decent amount of work. Let's see, we're going for about 2 hours now. Lives, menus. I'm not seeing how lives being a separate game state would help. Really, the issue is a logic issue here, where we are removing the life, and we also unconditionally spawn the ship, right? So if this hits 0, then we don't actually want to spawn a ship. So realistically, this remove life event might need to handle that. But like I said also before, we also do have a bug. So this spawning logic is already an issue. And we do need to move it out into a separate system, which is going to be a little bit more work. I think that that's next stream's topic for sure. So let's see where we are now. This is the game so far. We've got technically settings, audio playing. I don't play the audio through the stream, although we do have audio. I probably won't do audio on stream because it's a little bit awkward to like keep replaying the same thing over and over. And then exit will exit the game. New game starts a new game. We get to choose any of these ships. We are just spawning that in the middle of... Okay, yeah. The way that meteor spawns in is actually the issue. Hilariously. We need to change that back to random. So let me go here, create an issue. Meteors always spawn at 0, 0. This is an issue because the ship immediately gets destroyed. New ship spawns. Should wait for clear area. So this will be a to-do. And then meteors. I guess meteors being spawned randomly isn't really what we need. We need to do level design for each of that, because none of them should really be at 0, 0 when we start. So meteors should spawn not at 0, 0. And randomized. And then, did I respawn this yet? Or respawn, restart this? So then we've got new game. We can pick our ship. We can play. We've got the live system. Oh, that's a bug there. I think that's a bug in the physics collider library that we use, actually. I've seen this a couple of times. I haven't quite figured out what this is, what's going on there, but you can see the debug between the sprite and the actual collider is in the wrong spot. I know that the solver for Bevy XPBD is getting rewritten, and there's a huge like rebrand going underway. So I'm just kind of ignoring this issue right now because there will be a bunch of code changes. But suffice it to say, if I hit the orange circle, that will hit the ship. So our next issue is we have this kind of like game over state, which is just the menu, which means that we need that ship to despawn at some point. I actually don't know what happens if the meteor hits that ship again. But the ship collision should stop on the meteor, on the, like the game over screen. And that ship probably shouldn't even be there. We should never see a ship on the game over screen. So we'll just despawn on game over. New game. On game over screen. Ship persists and should not. And then on new game, clear meteors and reset life count. All right, so we'll consider those like our new game bug fixes. And then this game is pretty much over, I think. So it'll be that stream. We need to do scoring probably at some point. I don't know how the scoring for Asteroids works, being perfectly honest. I think it's related to how many meteors you destroy and how many UFOs you destroy. So we could do UFOs in the future. We could do scoring. And we could do like real asteroids levels. So as asteroids goes from level to level, the number of meteors that are spawned in goes up and they disappear. So right now, whenever I destroy a meteor, more spawn in. That's not how that's supposed to work. That's just for testing. So let's add levels, and levels will be in asteroids. Levels start with a number of meteors. And level ends when they're destroyed. In our game, meteors keep spawning. We should implement levels. Okay, so we'll implement levels. Let's do a one for UFO. Asteroids has UFO antagonists. Code some UFO AI. And then we need a scoring system too. Destroy meteors and UFOs, gain points. Bigger meteorites? We already have 3 sizes of meteors. I think for this one in particular, we're going to stick pretty hard to like what Asteroids is, like the way it used to exist. So Asteroids already has like game mechanics, right? Let's click on Wikipedia. So like this version of Asteroids, right? You've got score, you've got ship lives. Each level starts with a number of meteors. At some point, a UFO goes onto the screen. There's particles when meteors explode. There's 3 levels of meteor. I think that is generally what we're going for here. And then we'll do a different, like we'll just finish that game and then we'll have a different game where we do some kind of maybe space thing or move on. We'll see what people want on the stream. This is only my second stream this year, so last Saturday, this Saturday. We'll do next Saturday too. Next Saturday will also be Asteroids. But my goal is to get this wrapped up and then move on to a new one. That's kind of like the thing I want to do on these streams is build games, finish games, right? I think the finishing part is really important. This Asteroids game, we may just ship to like itch.io or something. I don't know that it makes sense to put on, you know, Steam or whatever. You'll vote for 3D game. I haven't implemented a vote yet, but if y'all keep showing up in chat and whatever, I will take whatever y'all want into account for whatever we work on after this. This will probably take us another 2 streams, looking at the amount of work here. Scoring, I don't anticipate to be very hard. Levels and UFOs will probably take like an hour each. New game, I'll probably allocate an hour for that just because it's not going to be terribly hard. But it is a task that needs to be done. So yeah, that's about 2 streams worth of work. I think the live system might be done. Yeah, show lives in UI. I made this a different one. I already converted that to an issue, so done on stream. Yeah, so I think this is all we need to do to finish the game. And then probably after this, I'll take it up off stream and I'll refactor it a bit. I'll make things a little bit cleaner. And I might turn that into a workshop, depending. We'll see. But yeah, I think this will only take 2 more streams and then we'll start on something else. So I think that's it for today. Thanks everyone for hanging out, and I will catch you on Saturday. Have a great rest of your day.